Welcome to UPSC Study Academy, empowering aspirants and shaping futures.
Welcome, everyone. Today, we are diving into the fascinating world of VSAT, or Very Small Aperture Terminal. This remarkable technology plays a crucial role in modern communication, enabling us to transmit and receive data via satellite, no matter where we are on the globe. Whether it's providing internet access in remote locations, ensuring reliable communication at sea, or supporting emergency response efforts, VSAT is a key player in connecting our world. Let's explore how VSAT works.
What is VSAT? VSAT stands for Very Small Aperture Terminal. It refers to a small ground station with a dish antenna that communicates with satellites. SATs are used for transmitting and receiving real-time data, providing two-way communication between the ground and space.
What are the segments of VSAT? Consist of two main segments. Ground segment. This consists of the VSAT equipment on Earth, including a small dish antenna, a transceiver, and a modem. The ground segment transmits data, which can include video, audio, and other data signals to the satellite. Space segment. This includes the satellite orbiting the Earth. The satellite receives the data signals from the ground segment and retransmits them back to another VSAT station, or to a central hub station on the ground.
Two-way communication. One of the critical features of VSAT is its ability to provide two-way communication. This means that data can be both sent and received by the VSAT station. This bidirectional communication is crucial for various applications such as internet access, voice over IP, VoIP, video conferencing, and remote monitoring.
What are the VSAT equipment? Dish antenna. This small, typically 0.75 to 1.2 meters in diameter, receives and transmits signals to and from the satellite. Transceiver. This device is mounted on the dish antenna, converting the data signals into radio signals for transmission and vice versa. Modem. The modem modulates and demodulates the data signals, converting them into a format suitable for transmission over satellite links. Outdoor unit. ODU includes the dish and transceiver, which handle the physical transmission and reception of signals. IT lies in the line of sight of the satellite. Indoor unit. IDU includes the modem and possibly other networking equipment, which interface with the user's devices and networks. It is used for interference with user's device. The both indoor unit and outdoor unit are locked with the help of a cable.
What are the different configurations of VSAT? There are 5 main configurations and topologies. Star network, hub-and-spoke central hub relays communication between remote SATs. Mesh network, direct communication between SATs without a central hub. Hybrid network, combines centralized management and direct communication. Point-to-point, direct link between two specific SATs. Center hub station, centralized node handling data processing and routing in a star network, crucial for managing large and complex VSAT networks.
Star network, hub and spoke. Configuration. The structure of star network. Central hub station and multiple remote VSAT terminals. All remote SATs communicate through the central hub. Working of star network. Data transmission from remote VSAT. End-user device sends data to the remote VSAT. Remote VSAT transmits the data to the satellite. This is called uplink. Satellite relays the data to the central hub. This is called downlink. Data processing at central hub. Central hub receives and processes the data. If the data is for another remote VSAT, the hub prepares it for retransmission. Data transmission to target VSAT. Central hub transmits the processed data to the satellite, uplink. Satellite relays the data to the target remote VSAT, downlink. Target remote VSAT receives and delivers the data to the end-user device. Applications of star network. Corporate intranets, banking networks, retail POS systems, internet access.
Mesh network configuration. Structure of the mesh network configuration. Multiple remote SATs interconnected. Each VSAT can communicate directly with any other VSAT. Working of the mesh network configuration. Direct VSAT to VSAT communication. End-user device sends data to the remote VSAT. Remote VSAT transmits the data to the satellite, uplink. Satellite relays the data directly to the target VSAT, downlink. Target VSAT receives and delivers the data to the end-user device. Applications of the mesh network configuration. Military and emergency services, oil and gas field communications, remote collaboration.
Hybrid network configuration. Structure of hybrid network configuration. Combination of star and mesh network elements. Central hub for general communication and direct VSAT to VSAT links for specific needs. Working of hybrid network configuration. Data transmission via central hub star. Similar to star network. Remote SATs communicate through the central hub. Direct VSAT to VSAT communication mesh. Similar to mesh network. Direct communication between remote SATs as needed. Applications of hybrid network configuration. Large-scale corporate networks with diverse communication needs.
Point-to-point configuration. Structure of point-to-point configuration. Direct link between two SATs. No central hub involved. Working of point-to-point configuration. Direct communication. End-user device sends data to the originating VSAT. Originating VSAT transmits the data to the satellite, uplink. Satellite relays the data directly to the receiving VSAT, downlink. Receiving VSAT delivers the data to the end-user device. Applications of point-to-point configuration. Dedicated links for specific enterprise applications. Secure communication channels.
Center hub station configuration. Structure of center hub station configuration. Centralized node. Acts as a major node in a star network. Multiple remote SATs. All communication routes through this central hub. Hub equipment. Includes powerful transmitters, receivers, network management, and data processing equipment. Working of center hub station configuration. Inbound communication. Data transmission from remote VSAT. An end-user device sends data to its local remote VSAT. Uplink to satellite. The remote VSAT transmits the data to the satellite, uplink. Satellite relay. The satellite relays the data to the central hub, downlink. Reception at central hub. The central hub receives the data and processes it. Data processing at central hub. Data handling. The hub processes the received data, which may include routing, error correction, and data management. Routing determines the destination of the processed data, e.g., another remote VSAT or an external network like the Internet. Outbound communication. Data transmission to satellite. The hub transmits the processed data to the satellite, uplink. Satellite relay. The satellite relays the data to the target remote VSAT, downlink. Reception at remote VSAT. The remote VSAT receives the data and delivers it to the end-user device. Applications of center hub station configuration. Large corporate networks. Suitable for managing and controlling extensive corporate intranets. Broadcast networks. Efficient for distributing television and radio content. Internet service providers. ISPs useful for providing internet access to remote and underserved areas. Banking and financial networks. Ideal for secure transaction processing and connectivity for ATMs and branch networks.
Importance of satellite transponder. A satellite transponder is a subsystem that serves as a critical link between the transmitting and receiving antennas. Its name is derived from a combination of transmitter and responder, reflecting its dual functionality. The transponder receives the uplink signal from the Earth station, amplifies it, changes its frequency to avoid interference, and then retransmits it back to Earth. This process enables the transmission of data, voice, and video signals via satellite. Each satellite can have multiple transponders, each operating on different frequencies.
Applications of VSAT. VSAT technology is versatile and used in many applications, including rural and remote internet access, providing connectivity in areas where traditional broadband is unavailable. Maritime communication, ensuring ships have reliable communication links at sea. Emergency services, facilitating communication in disaster recovery and emergency management. Corporate networks, connecting branch offices in different locations to a central corporate network.
Don't forget to like, share, subscribe, and hit the notification bell so you won't miss the next part of our series on communication systems. Thanks for watching.